Hello, my dear students. Today I will take up a new chapter, that is Class 9, Chapter 4, Structure of an Atom. So, in this, the topics to be covered are Introduction, Discovery of Charged Particles, Thomson Model of an Atom, Rutherford Model, Bohr's Model, Distribution of Electron in Different Orbits, Valency, Atomic Number, mass number, isotopes and isobars. Okay. Okay. So in your first chapter you have studied about the matter. What is matter? So anything which occupies space and has mass is known as matter. So for example, chair, table, pen, paper, or you can see in the image glass, ice cream, your favorite, gold, air. So all these are the matter. So matter is anything which occupies space and has mass. So this matter, it is made up of small particles called atom. Okay, or it is in the olden days or before this, it was also called as paramanu, but recently it is called as atom. Now we will use the atom. Okay, so in this chapter we will study how the structure of the atom is. Okay, so what actually is there in the atom? So is there any small particles in the atom? So is the atoms really indivisible? So you know, in the last chapter you have studied about the Dalton's theory. So he told that atoms are indivisible. So are they really indivisible? So we will see here. Okay, and we will study about the subatomic particles. So here subatomic particles, which are those? The protons, neutrons, electrons. So these are called as the subatomic particles. So these subatomic particles, they have charge in them. So the charged particles, how do we test that? We will do a small activity. So you try this out in your home. You take a small comb and take a pieces of paper. What you do, you rub the comb on your hair and then you place this comb near the small pieces of paper. So does this comb attract the small pieces of paper? You have to do and tell me. And one more you can do, take a glass rod and a silk cloth. So rub this glass rod with a silk cloth and then bring the rod near the balloon. So what do you observe? So from this activity we can conclude that on rubbing two objects together, will they produce electricity? So or we can say, will they become electrically charged? Yes. So where does this charge come from? So this question can be answered that an atom is divisible and consists of the charged particles. So in the Dalton's theory, he was told that atoms are indivisible, but actually the atom is divisible and it consists of the charged particles. Okay, so only when you rub the glass rod to the balloon, the electrically they were charged and the comb attracts the pieces of paper. Okay, so many scientists, they tried to reveal the presence of the charged particles in the atom. Okay, so one by one we will study how these charged particles were discovered. So first we will study the discovery of electron. Electron was discovered by J.J. Thomson. Okay, so before this, the one more scientist named Faraday. So Faraday in his experiment, he concluded that gases conduct electric current. Gases conduct electric current. So there are some conditions. So what are those conditions? At low pressure. At low pressure and high voltage. High voltage. Okay, so Faraday in his experiment, he concluded that gases will conduct electric current at the low pressure and high voltage. So this principle was known by the Thomson. So he used this principle in his experiment. So Thomson used Faraday's principle in his experiment. So what he did? Thomson, he took a Crookes tube. Crookes tube. Crook is the name of the scientist. So here you can see the tube. This is called as Crookes tube. It is a glass tube which is around 16 centimeter long. Okay. So in this tube, he took metal electrodes. Here you can see the metal electrodes. So these are connected by the wires. Okay, and a small tube you can see here. A small tube, it is attached as the vacuum pump to reduce the pressure. Okay, next he took a gas which has low pressure. Inside the tube he took a gas and he passed the electric current. When he passed the electric current at high voltage, so with the high voltage he passed the electric current through a gas which has a pressure of 1 atmosphere. Okay, so during this time he did not observe any change. That means there was no change observed in the tube because the gases were non-conducting. Gas did not conduct any electric current. So in the second time what he did, he reduced the pressure to 10 raised to minus 2 atmosphere. So that time the whole tube started glowing. Glowing in green color. Okay. So next in the third time what he did, he again reduced the pressure to 10 raised to minus 4 atmosphere. That time the whole tube stopped glowing, but the faint green was still seen at the anode. Okay, so to confirm this green color at the anode, what he did, he took a fluorescent screen. So this screen, it was placed at the back of the anode, and anode was made perforated. Here perforated means holes will be present. So what he did, to confirm this, he took the anode and it was perforated, means like this holes will be there. Okay, and behind this anode the fluorescent screen was placed. So this is made up of zinc sulfide, ZNS screen. Okay, so then he again passed the current through this with the same physical condition, that is 10 raised to minus 4 atmosphere and high voltage. Okay, so the ZNS screen started glowing. So this will confirm the rays. Okay, so by this experiment, what was the conclusion observed? So here in this experiment we can conclude that at low pressure, okay, at low pressure and high voltage, the rays were emitted from the cathode. So this is a tube, this is cathode and this is anode. So the rays were observed here, right, at the anode. That means where does these rays come from? These rays were emitted from cathode. So the rays were emitted from the cathode and they were moving towards the anode. So these rays, they are called as cathode rays. So these rays, they consist of negatively charged particles called electrons. Clear? So this is how the electrons were discovered. So at low pressure and high voltage, rays were emitted from the cathode and they were traveling towards the anode. These rays are called as cathode rays. Cathode rays are nothing but the beam of electrons. Okay. So these are negatively charged particles. Hence they were moving towards the anode. Anode is positive and cathode is negative. So negative will attract positive. Hence these negatively charged particles, they were moving towards the anode. Clear? How the electrons were discovered? Okay. Next we will study the discovery of proton. So how the proton was discovered. So E. Goldstein discovered the protons. Okay. So this was actually discovered while carrying out the experiment to produce the cathode rays. So when cathode rays were discovered, at the same time the protons were also discovered. So the apparatus used is same. So you know how cathode rays were produced. Okay. So when cathode rays were produced, they traveled through the gas in the discharge tube. So while doing this, the gas was ionized. Gas was ionized. Ionized means, ionization means the formation of the positive and the negative particles, charge. Okay. So here that is, they took the electrons of the gas, leaving behind the positively charged particles of the gas. Suppose this is a gas. So the cathode rays were produced. So while moving through the tube, they took the electrons of the gas. So from this gas the electrons were taken and here only the positive charge was left behind. Okay. So these positively charged particles of the gas, they emitted a rays called as canal rays. Here you can see. So these rays, they were moving towards the cathode. Cathode is negative. So negatively charged, cathode is negative. So the positively charged particles from the anode, they are moving towards the cathode. Okay. As these particles possess positive charge, so they were named as proton. Okay, so the positively charged particles are known as proton. So this is how the proton was discovered. Okay, we'll stop here. We'll continue in the next session. Thank you.